Hello and welcome to a new video on IGCSE Classified Physics Paper 2. In this video, we shall be discussing the topic of lenses. So before we start, I would like to give you a small model just to remember the cases of lens image formation. So we have a lens here, and the lens has something called a focus on either side. And then we have a distance of 2f as well that we're interested in. And we'll just extend the axis a little bit. So this is a summary of the cases of image formation. We have three objects, one at 2f exactly, one at a distance slightly more than 2f, let's say it's at 2.5f, and a third arrow at maybe 1.5f. So these are three cases that you need to be aware of, and you need to be aware of what happens on the other end. So the general rule here is that the distance between the object and the image is roughly 4f. So this is the distance between each object and its image. Now, one other thing you need to be aware of is that the distance is proportional to the size. And this will help us determine the size of each image. So let's start with the object that was at 2f, the green object. So the distance here is 2f. So the distance on the other side is going to be 2f as well, because the total is 4f. So 4 minus 2 is basically 2. And since they both have the same distance, they're going to both have the same size as well. So the green has the same size as the original. Now, what about the black object? The black object was at a distance of 2.5f. So the black image is going to be at a distance of 1.5f, because 4 minus 2.5 gives us 1.5. So the black image is going to be somewhere here between f and 2f. And the size of the image is going to be smaller because the distance is smaller. It's 1.5 instead of 2.5. Finally, for the yellow object, the distance between the object and the lens is 1.5f. And we said that the total distance is 4. So if we do 4 minus 1.5, we get 2.5. So we have 2.5f here. And since the distance of the image is larger than the object, so the size of the image would be larger than the object as well. So this helps us remember three of the cases. If the object itself is at 2f, the image will be at 2f and will have the same size. So same distance, same size. This goes for the green object. For the black object, if the distance is larger than 2f, so 2.5f, the distance of the image will be smaller than 2f, because we said the total has to be 4. So the distance is going to be 1.5f. And since the distance of the image is smaller, in the case of the black, the size will be smaller as well. Finally, for the yellow object, the distance is 1.5f. So it's somewhere between f and 2f. We just take 1.5 as an approximate value. So the image will have a distance of roughly 2.5f and will be larger. These are the three cases of real images. And they have the following properties. They are real and they are inverted. So these cases are important to memorize. We have one final case. Let's draw a new lens. We have f here. What if the object was at a distance less than f. So this is the object. So the image is going to be magnified, but it's going to be virtual. So it's going to be virtual, and it's going to be upright, and it's going to be magnified. So this is the fourth case you need to know about. And this is used in what we call the magnifying lens. This is the case of the magnifying lens. This was a short introduction to the concepts. Now we'll begin to solve questions. We will begin with general concepts. Which diagram shows the formation of a real image of an object placed in front of a converging lens? So you need to know that a real image is formed by the intersection of or the convergence of light rays. This is what gives you a real image. So we're looking for a diagram where the light rays are converging. So definitely not this one. Definitely not this one because they are diverging. This is very weird because they are being reflected. So again, this is incorrect. The correct answer here is choice D because you can see that the light rays are converging. So D is the correct choice. Which diagram shows a converging lens from a real image? Excuse me, which diagram shows how a converging lens forms a real image of an object O? Again, we're looking at converging rays that meet at a point. So the correct choice here would be choice A. Which ray diagram shows a converging lens forming a real image of a small object O? This is another question that tackles the same idea. We are looking for choice D because this is where the light rays converge. We're going to now move on to the three-ray diagram. So the three-ray diagram is an interesting method of determining where the image of a lens is. The diagram shows rays of light passing through a converging lens, which labeled arrow represents the focal length of the lens. So here is what we need to know about the three-ray diagram. We have a lens, we have an object. So we have three light rays that we use in order to figure out where the image is formed. The first ray moves parallel to the axis and it hits the lens and then it passes through the focal length or the focus. So this is the first ray. And then the second ray moves through the origin and passes by without any deviation. And the third ray moves through the focus of the lens, hits the lens, and then emerges parallel to the axis. And then these three rays are going to meet at a point, and this is where the image is formed. So anything that starts parallel to the axis emerges passing through the focus. Anything that starts moving through the focus will emerge parallel to the axis. Now, in this question, we are required to find the focal length. So we just look for a parallel ray. We're looking for a ray that was incidentally parallel. So here it was parallel. Then it emerges passing through the focus. So this is where the focus is. So in order to get the focal length is the distance between the focus and the center of the lens. So this distance here is the distance we call the focal length. So the correct choice is choice D. The student draws a diagram representing three rays of light from point P passing through a converging lens. Each point labeled F is a principal focus of the lens. Which of the rays has the student drawn correctly? Like we said, we have three rays, one parallel ray that emerges passing through the focus. So ray X is correct. Another which passes through the origin and then does not deflect at all. There's no change in direction. And then it keeps on moving until it meets the first ray. And then finally, So of course, this second ray is also correct. Excuse me. This ray is also correct. Now, the third ray passes through F and hits the lens. And then we expect it to emerge parallel to the axis. So ray Y should have been parallel to the axis. So which of the rays has the student drawn correctly? So ray Y is incorrect, but ray X and ray Z are correct. So B is the correct choice here. An object is placed 20 centimeters in front of a thin converging lens. The scale drawing shows how the lens forms a real inverted image. Which row gives the focal length of the lens and the distance of the image from the lens? So first of all, let's observe the scale here. So the scale is 5 centimeters and it represents 10 boxes. If you count the number of boxes here, you have 10 boxes equivalent to 5 centimeters. So 2 boxes would give you 1 centimeter. So anyway, in order to get the focal length, it's the distance between the center and the focus. Where is the focus here? So for a ray that is moving parallel to the axis, it should emerge passing through the focus. So therefore, the focus should be at this point here. And this point here is roughly 8 boxes away. So 8 boxes, if we use the ratio we wrote above, you just multiply here by 4. You have to multiply by 4 as well. And you get 4 centimeters. So the distance between the focus and the center is 4. We already know that A is the correct answer. However, if we were to try to find the distance of the image, so the image is located at this point here. And this point, if we move up like this, it's exactly one big box away from the image. One big box is 5 centimeters. So we're looking at 5 centimeters for the distance of the image. So therefore, A is the correct choice. An object is placed in front of a thin converging lens. The diagram shows the paths of 2 rays from the top of the object. An image of the object is formed on a screen to the right of the lens. How does this image compare with the object? So in order to figure this out, basically what you have to do is just extend the rays. So let's draw an extension of each ray. So let's draw this ray here and keep on drawing. And let's extend this ray as well. So they meet somewhere here. And this is the image. And you can tell, of course, that the image here is going to be bigger than the object. So therefore, it is larger and it is inverted because we can also tell that the image is upside down. So it's larger and inverted. So A is the correct choice here. A student draws a ray diagram to show how a converging lens of focal length f forms an image of an object. He draws 3 rays to locate the image. He then adds a 4th ray after the position of the image is known. Which of the labeled rays must have been drawn after the position of the image was known? So like we said, we draw 3 rays in order to locate the image. And the 3 rays are as follows. First, we begin with the ray that is parallel to the x-axis. It hits the lens and then passes through the focus. Then we draw a ray passing through the center. It emerges without any deviations. Finally, we draw a ray that passes through the focus, hits the lens, and emerges in path. These 3 rays intersect at a point, and this is where the image is formed. These are the only 3 rays that we can draw before locating the image. So we are using these 3 rays in order to locate the image. However, the question is asking which ray was drawn after the position of the image was known. So for the fourth ray, ray A, this could not have been drawn unless the position of the image was known in advance, because you don't really know how to bend the ray unless you know where the image is. Because like we said, we only have three rules that cover either a parallel ray, a ray that passes through the center, or a ray that passes through the focus. So for the fourth ray, the yellow ray, this is a weird ray that we cannot draw in advance. However, if we already know where the image is, we can easily just draw a line from the object to anywhere on the lens. So I'm just going to draw a fifth ray to explain that. I could have, for example, drawn this ray here, and then it hits the lens at this point, and then I know that it's going to diverge in a certain way so as to reach the image. But had I not known where the image was in advance, I could not have drawn this part. So for the yellow ray and the black ray, these would not have been drawn unless the image was known in advance. So the correct choice here would be choice A. The diagram shows an object O in front of a thin converging length of focal length F, at which point will the lens form a sharp image of the object. So we have object O here, and we want to know where the image will be formed. So of course, this obviously looks like it's either at 2F or maybe even slightly more than 2F. So we expect the image to be somewhere near 2F as well. And we expect the image to be inverted. So D makes perfect sense. The incomplete ray diagram shows two rays of light that have passed from one point of an object through a thin converging lens. Which type of image is formed and on which side of the lens is it formed? So as you can tell here, the rays of light are diverging. So this will keep moving this way, and this will keep moving that way. They're never going to meet. And in this case, this is the case of a virtual image being formed. How do we know that? If you plot backward extensions of each ray, they're going to meet somewhere here, and the object will be upright and magnified and virtual. How do we know that it's virtual? Because it is not formed by the actual intersection of rays, but rather by backward extensions of the rays. So this is a virtual image, not a real image, and it's formed on the left. So the correct choice here is choice C. A converging lens is used to make an image on a screen. What type of image is formed on the screen? So you should know that only real images can be formed on a screen. So it's definitely not virtual. And we said before that any real image is formed by inverted rays. So if we have an object here, we said that it moves, we draw these two rays and we see where they intersect, and then we draw the image. So the image is always inverted. So one key point here is in lenses, if an image is real, it will definitely be inverted. You will never get a real upright image. So we always have a real and inverted image. So A is the correct choice here. The diagram shows a parallel cylindrical light beam of diameter d incident on a thin converging lens. A screen is placed at a distance equal to two focal lengths 2f from the lens. Which diagram shows the size of the spot of light seen on the screen? So from the model that we explained at the beginning of the video, we said that the distance between the object and the image is roughly 4f. And therefore, if we have an object at 2f, we know that the image is going to be at 2f as well. And since they are at the same distance, they will have the same size as well. So we have same distance, same size. So we're looking for a beam that has a size or a diameter of d, and therefore C is the correct choice here because it's the only one with the same size. Now we move on to questions that have to do with a magnifying glass. The diagram shows a converging lens forming an image of an object. Which statement about the image is correct? So is it real or is it virtual? Of course, here it's virtual, not real, because we can clearly see that it's formed by the backward extension of rays. And we said that this only applies to virtual images, whereas real images can actually be formed by the intersection or the convergence of rays. Now, can it be seen by eye at X or at Y? So the thing is, this is the case of a magnifying glass. So imagine you're trying to look at something very small and you're holding a magnifying glass and you have the object on the other side. So do you put the magnifying glass between you and the object, or do you put it on the other side of the object? Of course, this does not make sense. You put the magnifying glass between yourself and the object. So your eye and the object have to be on opposite sides of the magnifying glass. So therefore, we expect the eye to be at Y, not at X. So therefore, the correct choice is D. A converging lens is used as a magnifying glass to view an object. Which statement is correct? So remember, this is the case of the magnifying glass. We have F here, the object is here, and the image is here. This is the object, and this is the image. So is it inverted? No, it's upright. Is it, excuse me, is it nearer the lens than the object? No, it's actually further away from the lens. It's behind the object. So this is incorrect. The image is of the same size. No, it's larger. The image is virtual. This is correct. So the correct choice here is choice D. The image is virtual. An image is formed by a plane mirror. A second image is formed by a lens used as a magnifying glass. Which row states the nature of each of these images? So whether the image is in a plane mirror or in a magnifying glass, they are both virtual images. This is something you need to know because they are both formed by the backward extensions of rays rather than the convergence of rays at a point. So D is the correct choice here. And this brings us to the end of our video. Thank you for watching. I hope this has been beneficial to you.